Greetings to you all. I just started the second session of propositions. In the first session, I left up to the truth value of conjunction disjunction. So I just recall, suppose if P and Q are two propositions, then P and Q, which is the conjunction between P and Q, P or Q, that is the disjunction between P and Q, are another propositions which has truth value P Q 1 1 1 0 0 1 0 0 and P and Q has 1 0 0 0. P or Q has truth value 1 1 1 0. So this is what we have seen in the last session. Now I go for the next conjunction, that is next connective. These are called connectives because it is connecting two propositions. So the next is conditional. Conditional. So conditional is if P then Q. That is, if P happens, then Q will happen. Or if P happens, what about Q? So these things is related with the notation P single arrow Q. If P then Q. So we can read this as if P then Q, or colloquially P implies Q. This is also another proposition with the truth value P Q 1 1 1 0 0 1 0 0. We have P implies Q has 1 0 is 0, all other thing 1. I explain here what is the meaning. If P happens, then Q happens. That is the meaning. So 1 means P happens and Q happens. So if P happens, Q also happens, then it is true. That is, the statement has logic, so it is true. And if P happens but Q does not happen, so it is false, because if P happens, Q must happen, but Q does not happen, so it is 0. If P does not happen, either Q happens or not, we need not bother, because if P does not happen, we need not check about Q. We need not check about Q. So if P does not happen, if Q happens, that is true. If both does not happen, then also it is true. I'll give some examples later after completing all the propositions. And one more conditional statement is biconditional. I'll write one more thing, biconditional. So for biconditional we have P, it is double side arrow Q. It is read as P if and only if Q. That is P if and only if Q. So what is its truth value? P Q 1 1 1 0 0 1 0 0. So for this we have P double imply Q. 1 1 is 1, 0 0 is 1, 1 0 is 0, 0 1 is 0. Okay, so I can give some example for this. a statement like if the teacher comes to the class, he will get attendance. He will get attendance. So this is the statement I started here. If the teacher comes to the class. So how you set P? P as teacher comes to the class. Teacher comes to the class. And Q, he gets attendance. So the first statement is P implies Q, that is if teacher comes to the class, he gets attendance, so it is true according to the statement. If teacher comes to the class but he will not get attendance, that is false, because if teacher comes, definitely he will give attendance, he will take attendance, he will give, so that is false. If teacher does not come to the class, whether the person is attending the class, whether the person comes to the class or not, that is immaterial. He will get attendance, because he cannot identify, the teacher cannot identify who comes, who did not come, and he will give attendance for all. That is the meaning. Okay, so this is the apt example for this 0, 1. So if the first one does not happen, we need not bother about the second one. That is the meaning. And here, suppose if I take this example, biconditional, I'll take one. So if he attends class, then only he will get score, or even he will get attendance. You can write attendance. If he attends the class, then only he will get attendance. That is the meaning. So here 1, 1, if he attends the class, he will get attendance 1. If he is not attending the class, he will not get attendance. That is also true. If he is not attending the class, he will not get attendance. And if he attends the class, he is not getting attendance, that is false. He attends but not getting attendance, so 0. If he is not attending the class, so that is the meaning of only he will. So then see the difference between then and only when. So only when means if the first one happens, then only the second one happens. So the first one does not happen, second one will not happen. So 0, 1 is also false. So that is the meaning for biconditional statement, like 1, 1 is 1, 0, 0 is 1. If it is changed, then it is 0. Okay. So we can see some examples relating to all these connectives. So I take some examples. So what are all the connectives we found here? Connectives, which is negation, conjunction, disjunction, conditional, biconditional. So with these 5 connectives, suppose if I take symbolizing, so common statement can be written in terms of these propositions, symbolizing the statements. Okay, so first, suppose if I write, he goes to college or to ground, never to temple. Okay, he goes to college or to ground, never to temple. So how do you define this? First you said there are three statements here. He goes to college, he goes to ground, he goes to uh, temple, not temple. So it is not matching here. So library you can take. So P as he goes to college. Q, he goes to ground. R, he goes to library. Here we have, you just connect, he goes to college. This R is the conjunction. Never is the conjunction, right? Never to. So it is in between comma, never to temple. So the comma, whenever you have comma, that is nothing but conjunction. For example, suppose if P comma Q, if I write P comma Q, that means P and Q. It is in usual language only. So if P comma Q comma something and the last one followed by the last one will be with and. But if it is only two, P and Q, so we will write it as P comma Q. Instead you can write P and Q. So wherever you have comma, that is meant for conjunction. So you will come in the derivations also. It will be given sometimes comma, sometimes conjunction. So you can mean that. So here we have he goes to college as P. How to symbolize? He goes to college as P and he goes to ground R. So R Q. But so you just complete this, the bracket. But he never go to library. So negation R. So just understand this concept. He goes to college or go to ground, never to library. You can write like this. Suppose if I write, if he does not go to college, he will not get attendance or he will not get score of marks, much marks. So we can take here P always. See here we can write simply P as he does not go to college and Q as he will not get score. But usually we have the prepositions, we have to take it as positive. So P as he goes to college and Q as he gets good score. So how you can write, if he does not go to college, that is negation P, he does not go to college, implies negation Q. In this way only you can write. Another example with the same I'll tell. Unless he has severe health issues, he will not go to hospital. So you can write here again positive statement. P as he has health issues. Q has he goes to hospital. So we can take unless he has health issues, he goes to hospital. how can you mean it? He will not go to hospital if he has not severe health issues. He has he has severe health issues. So you can take here, he will not go to hospital when he has not getting severe health issues. So negation Q, he is not going to hospital. Negation P, if he has not severe health issues, negation Q, he will not go to hospital. Right? And one more thing, I take it with negation. Suppose if I write, there is no proof that smoking causes cancer. Smoking causes cancer. So here for this we can write P. He is smoking. And Q, he suffers with cancer. Then if he smokes, he will suffer with cancer. It's not the case. There is no proof. So negation. The statement is not true. So if you take the statement is true and put negation, so smoking causes cancer is not true. Then you can combine many things together like P and negation Q, or some R, the whole thing to negation Q, something like. So this is called formula, a statement formula. Or I start with statement formula. So if you get many propositions with many connectives together, we will just frame it as a formula. I already told P, Q, R are simply variables. So with these variables, we can have some operations between them. So with the variable, with the operations, we can produce some expressions. So these expressions are called statement formula. So with these expressions, you can go for other operations. You can simplify the expression. You can find a particular truth value for the expression and so on. So for example, suppose if I take 2, suppose if I take only 2, okay, and I have P to Q and negation P, or something like if I take. So I'll take here 1, 1, 1, 0, 0, 1, 0, 0 and P to Q and negation P. So what is P to Q? P to Q is 1, 0 is 0, all other true. And negation P is here 0, 0, 1, 1 because whenever P is 1, negation P is 0. So when you combine these two, okay, so this is P implies Q, negation P. So P to Q and negation P is just combining these two. Negation, conjunction. Conjunction is nothing but if both are 1, it is 1. So 1, 1, 0, 0. So these are the truth values for this expression P implies Q and negation P. That means this expression has 0 when both P and Q are 1. The expression has 0 again when P is 1, Q is 0. When P is 0, Q is 1, the expression has 1. When both are 0, the expression has 1 as truth value. So it is nothing but the value of the expression we can say. Value of the expression we can say. So we can take this for 3 variables too. We can go for 3 variables and then we can produce truth table for that, and we can evaluate the formula. So whatever formula given, it may have more number of columns. You can add one by one and then finally you can reach the truth value of the entire expression. So this we will take it in the next section.